Ready for another deep dive? Let's jump in. Today we're tackling a real game changer in the AI world, AlexNet.
Yeah, and it's no exaggeration to say AlexNet totally changed how we think about computer vision and machine learning as a whole, really.
Right, we're talking total paradigm shift.
Okay, so let's rewind the clock a bit. It's 2012 when AlexNet makes its grand
The
entrance.
true game changer.
We've got some excerpts from the Dive into Deep Learning documentation to guide our deep dive today. And back then, AI was, well, it was still kind of fumbling around when it came to image recognition. Like imagine trying to teach a toddler to identify a cat from a blurry old Polaroid
You're
picture.
saying, yeah.
Remember those early digital cameras? Cost you a fortune, and the pictures were, well, let's just say they weren't exactly high definition.
Definitely a different era for data. That's the kind of limitation we're talking about here. Data limitations galore.
It's kind of like trying to teach a computer to paint like a master, but all you've got are those blurry Polaroids to work with. Not exactly a recipe for success.
Exactly. You're stuck with these terrible tools. And speaking of tools, let's talk processing power. Today's smartphones, they'd be like supercomputers back then.
Oh, absolutely. We've come a long way.
Researchers were stuck hand-coding features, basically telling the computer exactly what to look for instead of letting it learn on its own.
Talk about a tedious approach.
Can you imagine?
Yeah.
The ultimate programmer's nightmare?
Yeah.
Talk about tedious. But then along comes this thing called the ImageNet challenge, like a massive visual IQ test for AI. You know, a million images, thousands of categories.
Yeah, it really shook things up.
It was like the Olympics of computer vision. And AlexNet, well, it came out of nowhere and just, like,
Stole the show.
completely, totally crushed the competition.
Error rates significantly lower, like way lower than anything we'd ever seen.
Mic drop moment. Right. They did not see it coming. Okay, but here's where it gets really interesting. AlexNet wasn't some brand new invention.
Right?
It was actually based on this older network, LeNet, from way back in 1995.
Yeah, it's true.
And they shared some similar building blocks, these two networks, but their impact, worlds apart. So what changed?
That's the million-dollar question. Honestly, I think it boils down to two major factors: data and hardware.
Okay, so unpack that for us.
Well, ImageNet, it provided that massive data set that deep learning was, well, craving, basically. And then the gaming industry. Believe it or not, they ended up providing the hardware.
Wait, gaming? You're kidding. Tell me more about that.
Not kidding, it's true. GPUs, those things that make your video games look all cool and stuff.
Yeah.
Well, they were initially designed for rendering graphics, but they turned out to be perfect for the kind of parallel processing that CNNs need.
It's funny how these like totally separate fields can just collide and spark these huge innovations.
You'd never think it, but
So our sources mention that AlexNet was trained on these GTX 580s, top-of-the-line gaming GPUs back in 2012.
oh yeah, each one with a whopping 1.5 teraflops of processing power, which, to be fair, was unheard of back then.
That's insane. Okay, so we've got this like perfect storm brewing, the data explosion, the GPU revolution.
Hmm.
But AlexNet's secret sauce, it went beyond just hardware and datasets, didn't it?
You're definitely right about that. The architecture itself, it was, well, cleverly designed, to say the least.
Okay, so how so?
Take a look at figure 8.1.2 in our source material if you want to follow along at home. You'll see these massive, like really big, fully connected layers at the very end of the AlexNet structure. Those were really key to its power.
But those massive layers, they must have been a pain to actually deal with, right? It's like trying to stuff a giant suitcase into a tiny overhead bin on a plane, you know?
You could say that. Yeah, they definitely demanded a lot of memory, a lot of processing power, which back then presented some serious challenges.
So you're saying it's kind of like owning a super fast sports car that's amazing to drive, but also guzzles gas like it's going out of style?
Yeah, that's a pretty good analogy. But even with those challenges, AlexNet's performance was undeniable. It really proved that deep learning was the future of computer vision, you know?
Absolutely. So let's unpack these architectural innovations a little bit more, because I think that's where things get really, really interesting. What else did AlexNet bring to the table? So it was clearly more than just a bigger, badder network, this AlexNet thing. It sounds like they really changed how it learned, too.
Exactly. And a big part of that was this new concept. Well, it wasn't brand new, but AlexNet really popularized it. Something called ReLU.
ReLU. Okay, and that's
That's short for rectified linear unit.
catchy.
Yeah, they always do that in this field, right? But basically, it's a type of activation function.
And sticking with me, everyone, because I know this is where it gets a little nerdy, but trust me, it's interesting. Can you give us, like, the ELI5 version of what an activation function is, though.
Sure, sure. Think of them like little decision makers inside the neural network.
Okay.
They decide how strongly a neuron reacts to the information it gets.
So is RealU like a super efficient decision maker then? Is that what makes it special?
Exactly. That's a great way to put it. See, older networks were using something called sigmoid, which is more like, imagine a dimmer switch, smooth, gradual changes in the output.
Okay, yeah.
Real use more like a light switch. It's either on or off, 0 or 1.
Interesting.
And that simplicity, it makes a big difference, faster calculations, more efficient training overall.
So RealU really helped AlexNet train quicker, get those impressive results.
Definitely a contributing factor. And speaking of training, our sources also mention this technique called dropout.
Dropout. Did AlexNet get bored, like slacking off during training or something?
No, not at all. It's actually the opposite. Dropout is this really clever way to prevent something called overfitting.
Which is?
Oh, sorry. Overfitting is, well, imagine you study way too hard for a test, like you memorize everything.
Been there.
Right. But then you walk into the actual test and you totally blank.
Oh, I see. Because you didn't actually learn the material.
Yeah.
You just memorized it without understanding.
Exactly. And overfitting is kind of like that for neural networks. It gets really good at recognizing the specific data it trained on, but then can't handle new information.
So it's like the network needs to learn to think on its feet, be more adaptable.
Right. And that's what dropout helps with. It randomly turns off some of the neurons during the training process.
Oh, interesting.
Yeah, so it's like forcing the network to find different paths to solve the problem, making it more robust in the process. And then, on top of that, you have data augmentation. Another trick up AlexNet's sleeve.
Ah, yeah. I've heard of that one. That's where you show the network the same image, but like from different angles, maybe with different filters, right?
Yeah, you got it. It's all about giving the network that extra experience, like showing a kid a picture of a cat, but you show it to them from every angle, upside down, sideways, different lighting.
So they really get what a cat is, not just one specific picture of a cat.
Precisely. And that's what they did with AlexNet. Flicking images, cropping them, changing colors, all during training.
Wow. They really threw everything at it, huh?
They did. And it paid off. Those techniques, combined with RealU and Dropout, it all came together to give AlexNet that, well, unprecedented accuracy in image recognition.
The perfect storm of innovation. But, every superhero has their kryptonite, right?
Yeah.
So what about AlexNet's limitations? Our sources did mention an Achilles heel.
Yeah. Well, about those massive, fully connected layers we talked about, as great as they were, they came with a cost. How so? They were very computationally expensive, needed a ton of memory, tons of processing power to work.
So back to that sports car analogy. Amazing speed, but guzzles gas like crazy.
Exactly. And that limitation, it actually became a driving force for future research. It's what led to more efficient networks later on. Things like GoogleNet, VGG, and eventually what we use a lot today, ResNets and efficient nets.
So even in its limitations, AlexNet inspired the next generation of AI architects.
That's how it always goes. You learn from the best and you build upon it. That's how progress happens, right?
Right. So we've established AlexNet was a rock star back in the day, changed the game completely. But how does it hold up today? Is it still relevant in this whole crazy world of AI that just keeps moving faster and faster? So we've established AlexNet was like the rock star of its time. But does this still rock the AI world today? What do you think?
That's the big question, right? And it's tricky. I mean, on the one hand, looking at AlexNet's architecture now, it can feel a bit, I don't know.
Dated.
Yeah, kinda. Like comparing a first-generation smartphone to the latest model, there's a reason we've moved on.
Right. So more like a vintage classic than current chart topper.
Exactly. But its legacy, that's undeniable. AlexNet proved what deep learning could really do. It sparked a revolution.
Totally changed the game.
Completely. And everyone else they had to catch up.
Like that saying, a rising tide lifts all boats.
Yeah, that's a good way to put it. AlexNet raised the bar and everyone stepped up their game. Researchers started exploring all these new architectures and training methods, looking at different ways to use deep learning. It opened a floodgate.
And it's interesting because even those limitations we talked about, the massive layers, all that power consumption,
right.
They kind of became this driving force for even more innovation, didn't they?
Oh, absolutely. We wanted better, more efficient networks. And that's how we got things like ResNets, efficient nets. Those are the big players now.
So even the shortcomings, they push the field forward.
That's the thing about scientific exploration, isn't it? Every discovery, every obstacle, It teaches you something, gets you closer to understanding the full potential of, well, in this case, AI.
And speaking of potential, we've talked about how important data and computing power were to AlexNet's success, like absolutely crucial.
Yeah.
And now we've got even more data, more computational muscle than ever. What does that mean for the future of AI?
It's an exciting time, that's for sure. I mean, we're talking exponential growth in both those areas. Data and computing power, they're exploding. So, and in a way, we're entering uncharted territory, which is always a little scary, but mostly really, really cool.
It's like we've been handed a spaceship and this big blank map to a whole new galaxy of possibility.
Yeah.
What kind of crazy AI might we see in the next few years even? What problems could we solve?
It's hard to even imagine. I mean, we might have AI designing personalized medicine, creating art that's indistinguishable from human-made, maybe even helping us unlock the secrets of the universe.
It's kind of mind-blowing and a little intimidating if you really think about it.
It is. It is. But one thing's certain. This is just the beginning. AI's journey is far from over. Every breakthrough, from those early days with AlexNet to whatever comes next, it just brings us one step closer to, well, to seeing what this technology can really do.
Unlocking its full potential.
Exactly.
Well, on that note, I think we've done a pretty good job diving deep into AlexNet and the whole rise of deep learning.
Yeah, I think so.
And to everyone listening, we hope this has piqued your curiosity about, well, about the world of AI.
Yeah.
Because it is a fascinating world.
It really is, and it's changing all the time.
Exactly. The future is unwritten, right? Who knows what incredible breakthroughs are just around the corner.
So keep exploring, everyone. Keep asking questions, and never lose that sense of wonder.
Couldn't have said it better myself. Until next time.